What's up, everyone? This is LeetCode 139 word break. We've done this problem in Python. Now we're going to do it in C++. So we're given a string s and a dictionary of strings word dict. We have to return true if s can be segmented into space-separated sequence of one or more dictionary words. And we have to note that the same word in the dictionary can be reused multiple times in the segmentation. So basically, can we create the string s from a combination of the strings in word dict, and we can use these words more than once, right? If we can, we return true, right? Example 1, we can create the word LeetCode by segmenting leet and code. Here, the string s can be segmented by using the word apple, pen, and apple, so we return true. Example 3, right, we can use cats, and then the word and, right, cats and the word and, cats and the word and. Then we're left with OG, and we have dog, but no word that's just OG. Likewise, we can use the word cat, and then sand, right, cat and sand, but we're left with OG. And again, we only have the word dog, which is not an exact match, right, because we don't have a D in what's left over, which is just OG. So we cannot create this string s from any segmentation of sequence of segmentations of these strings, right? So we have to return false. So this problem seems kind of easy on the surface because of the problem statement. It kind of seems kind of simple, but it's actually a little bit complicated. The approach is a little bit complicated, and so I'm going to go to an illustration. Now, before I do that, though, I'm just going to reuse my Python video for the explanation because it's all visual. The actual code I'll show you in C++, but it's literally the exact same concept is going to apply in C++. I think in part of the video I talk about string splicing in Python, but it works very similar in C++. So don't get too confused on that. When I say string splicing in Python, I'm just referring to taking the substring. Just think of the substring equivalent in C++, right? That's all I'm talking about. Anyways, yeah. After that, I'll be back and I'll kind of explain the C++ implementation. Okay, so given that you're on this video, you probably tried something like a two-pointer approach, right? Like a sliding window, right? Where you expand your sliding window, right? So if we have something like this, where this is our word dict here, this is our string, right? If we have something like this, you might think, okay, Lee is a word in our string, or in our word dict, right? So let's move our sliding window over, right? And then you might look at like some of the substrings here. I can't speak. Some of the substrings here, you might look at it and you realize, okay, none of them exist in word dict. So you return false. But that's not the case, right? Because technically you can build out this string s by doing leet and code. But given that you're using a sliding window, you looked at Lee first instead of leet, right? So you should actually be returning true here, not false. And the problem with like a sliding window approach is there's just a lot of edge cases where that you have to account for, right? And so like a sliding window two-pointer approach is not efficient for this problem. It's going to trip you up on a lot of like test cases, and I know that because I tried that. So yeah, this problem is actually trickier than it seems. And this problem is actually a DP problem, right? That's how you solve this problem. You use DP, right? Dynamic programming. So I'm going to walk through that, and I'll try and explain as best I can. It's a little bit of a tricky problem, but I think I'll try and go slow and explain stuff. But yeah, okay. So we have our string s, right? And we're going to have to create a DP array. So we're going to create, I don't know if I can minimize this. Whatever. But anyways, this just says DP right here. So this is our DP array down here, and the length of the DP array is the length of s plus 1. Oh, if I draw, it goes away. Okay. So the length of s is, we take the length of s plus 1, and that's the length of our DP array. So our DP array is a little bigger. And this DP array here is actually a Boolean array, and everything is initialized to false initially. Okay. Initialized to false initially. That's a bit redundant. But everything is just false in this DP array, okay? Initially, except for the 0th index. That's actually true, because this is kind of like our base case, like our starting point for our algorithm, and it'll make more sense why we do this. But this is our DP array, right? It's a Boolean, and this is just the initializing part, okay? We haven't done anything special yet. And so the point of the DP array is we're going to basically build out combinations of words, right? We're going to look at the different possible combinations of words, because like up here, right? Like we technically could have leet, right? Like imagine we have some word like TCO also, right? We could like have this combination here, then this combination here. But however, we can also have the combination leet and code, but we need to find the proper combination that actually can build out the entire word, not just the partial like um segmentation, right? It has to be the full segmentation. We have to build out the entire string, right? And so the point of the DP array really is like if we get to this ending point here and this gets set to true, it means we found some combination of strings in worddict to where we can build out the entire string S, okay? And so this DP approach is very efficient for that. Okay, so the way we're going to do this is we're going to basically have a starting point, which is we're gonna iterate through this string S, okay? And we're gonna do that in a for loop. So we're gonna have an I, right? That's gonna start here initially. And so what we're going to do as we iterate through this, right? Initially I is at 0, right? Because we're in a for loop. And what we're going to do is we're gonna check wherever I is at a given point, like now. Now we're gonna check DP of I, okay? So what we're really checking is DP of 0. And if that's true, then we need to do something, okay? So let's go DP of 0, and oh, what do you know? DP of 0 is true, right? This is our starting point, so this should always be the case, right? Like I said, this is our base case for our algorithm, which is why this has to be true initially. So DP of 0 is true. Okay, so what we're going to do now is we're going to basically have a j variable, right? And j is going to be at I plus 1, okay? Now, in terms of like, because what we're doing now is we're going to look at certain substrings to see if they exist in worddict. Okay, now wherever j is now, you need to understand where should j end, right? How far should j go out? Should it go all the way out to here? I mean, think about it. Should it go all the way out to here every time? In every case? And the answer is it depends. Because you need to think about something in terms of efficiency for this algorithm, which is that when we're looking at substrings, we never want to have a substring that exceeds the longest length in worddict, right? For example, the length of the longest word here is size 4, right? Size 4, right? So when we're looking at like substrings, would we ever want to look at a substring like this long? Well, of course not, right? Because we would never have a substring that's of length 5 when our longest substring here should be 4, right? So why would we ever want to look at a substring that's of length 5, right? So we actually don't want to go this far out, right? And the reason I say it depends is because let's say our array ended here. Well, technically we don't want to look at a substring like this because we'd be out of bounds, right? So we basically want to take the minimum between the length of S and the longest length of the substrings in worddict, right? Yeah, the length of the longest word in worddict and the length of S, right? We have to take the minimum. Okay, and that's just like an efficiency thing. It'll make more sense in when we write our code, but I just want to mention that just so I don't drop it on you later and you're like, well, where did this come from, right? So I'm just kind of explaining that visually. But anyways, so technically, where should j end, right? So as far as j, right, in the for loop, in the inner for loop, j is going to start at I plus 1, right? And it should end at I plus 1 plus the longest length of the word in worddict, the length of the longest word in worddict. So this would be 4 plus 4 plus I is at 0 plus 1, so it should be at 5. So j should technically end here, but remember, in for loops, at least in Python, we technically, this is not inclusive, so our j technically goes here. This is our last index that we're going to touch. But because we're using Python, when we do string splices, right? When we do from 0 to 4, right? Remember, you need to keep in mind how string splicing works in Python, right? This is inclusive, this is exclusive. So the way this would work, right? And the way this would work is we're technically going from 0 up to index 3. Okay, so this is our longest substring. So because this is how string splicing works in Python, right? When we do from index 0 to 4, we're including index 4, but not index, or sorry, we're including index 0, but not index 4. So technically we're going from 0 up to, but not including 4. So we go from 0 to 3, and that's the length of our longest string in our substrings. The reason I mention all that is just I don't want to get you confused because, technically J is going to go up to here, but we're not going to include this index because you might look at this and go, wait a minute. Our longest substring should be 4, right? Not 5. Why is J up here? And it's because of how string splicing works in Python. Okay. But anyways, that was just kind of some preliminary tangential stuff to make sure you don't get confused, just to keep in mind on how we're going to make this algorithm efficient, right? So let me just go back to where we started. Okay. So I is at 0. We go to dp of I. That's true. Okay. So now we can go into an inner for loop. So we're going to set j to start at I plus 1. So j is going to start here. Okay. And we're going to say we're going to string splice from I to j, right? So from 0 to 1, but remember this 1 is not inclusive. So technically we're going from 0 to 0. So we're looking right here. Okay. Is this in our word dict? The letter L? No, it's not. And again, this example here, that is just this, okay? I'm just using this. So no. So we can move j over. Okay, so from 0 up to 2, but remember the string splicing doesn't include this index. So we're looking at this now. LE is not in there. Okay, now we move here. Okay, is this in our word dict? It is. So what we're going to do now is we're going to set dp of j to true. So dp of 3, right? So 0, 1, 2, 3. So now dp of 3 is going to be set to true. Okay, so now we move here, right? And again, we're looking at this substring now. Is this in our word dict? Yes, it is. So we set dp of 4, right? Because we're at index 4. Now we set dp of 4 to true. So we set this to true. And as you can see, in this approach, we're looking at both these substrings now, or both these words, right? Whereas like in the sliding window, we were only looking at this, or maybe you do like some weird like edge case handling where you handle both, but it just gets really confusing when you have a lot of test cases. And this is just more efficient, okay? So now, remember, our sliding window our substring should only go up to length 4. So now we're done with this part. So we're going to basically, we're going to move I forward, because remember, the whole point of this is that we're in a for loop checking every moving forward in the string s, right? Going like kind of linearly. So now we're going to move I here. So I at index 1. So dp of 1, well, that's false, so we're not going to do anything. So move forward. dp of 2, that's false. dp of 3. Okay, now this is true though, right? Because we look here and this is true. So now we're going to have to set j here, and we're going to basically look at this substring, at this substring, at this substring, at this substring, but we're not going to find anything, right? Because none of those substrings exist up here. So technically, it doesn't really matter. We're still going to look through it, obviously, in our code. Like, our code's going to run through it, but we're not going to find anything. So we move forward, right? And now we're at I is equal to 4. Well, dp of 4 is true, right? So we need to do the same thing. So set the j here, and we're going to look at this substring. It's not in word dict. This substring, not in word dict. This substring, not in word dict. This substring is in word dict, right? So because this is in word dict, we're gonna, when j is here, when j is here, right? We're going to basically put this here as true, right? Well, technically j is not at the 7. Sorry. Because remember, the way string splicing works is up to but not including. So technically, to include these 4, j should be here. So it should be at index 8, which we do have an 8 in the DP array. So this gets set to true, right? And then we keep going, right? I is right? I is going to keep moving forward. So dp of 5 is false. dp of we go a 6 is 6 false. Is dp of 6 have anything? No, it's false. dp of 7, no, it's false. And obviously we're dumb, so we never check dp of 8. But remember what I said, like the last index is super important. This is true. So what does this mean? It means that we found a combination of words that we can build out the string S, and we did, right? And so you can see with this DP approach that it's really beautiful because we're looking at the subs. So we found Lee, right? And then we check if we have we can build out the full word from here also. But at the same time, because we're using DP, we're also checking this and see if we can build out the word from here. So we're really looking at all the combinations. And if, like, when we find a certain substring like Lee, okay, let's look at all the combinations from there onwards. Oh, when we find Leet, let's look at all the combinations from there onwards. And so we're kind of looking at every combination, right, wherever we find substrings. And so that's why DP is so efficient here. Okay, so I hope this illustration helped. I know this video is a little bit long, but like I really want to run through this visually because it just makes the problem so much easier to understand. So if I write the code out, it's not going to make that much sense. But I think it should make sense now. All right, so let me write some comments out before we start coding. So just to explain our approach, right, just to make sure we're on the same level here, right, what we're basically going to do is we're going to start at the empty string, which is, of course, dp0, right? That's like our base case. It's our entry point for our algorithm. And we're going to find words that can be built from there, right? If we can find any words that can be built from there, we're going to mark the ending index as true in the dp array. And then we're going to keep kind of going forward in the string s, right? Like linearly in a for loop. And when we hit wherever those trues are in the dp array, from there on, we're going to also keep checking if we can build words from there and so on, right? That's how we're going to check all the combinations of possible words and see if we can build string S from the words in wordDict. Okay. If at the end, that index, right, which is the last index, right, the dp of s.length, right? If that is true, it means the string can be built, right, using words from the word dict. Otherwise, we return false. Okay. So let's start. So first of all, we're gonna get the length of s, right, and we're gonna create our dp array, right, which is, remember, a Boolean array. So it's gonna be length of s plus 1. That's a length. Remember, everything's gonna be initialized to false. However, dp of 0 should not be initialized to false. That should actually be true because that's really just it's really our base case, right? Right, it's our base case, and the empty string is always segmentable, right? Kind of like our entry point for our algorithm, okay? Now, we actually have to create an unordered set for O of 1 lookup. So what I mean by that is we're gonna find different substrings in S, right? And we're gonna see if those substrings exist in wordDict, but the problem is wordDict is an array. So when we basically check, does this substring exist in wordDict, that's not that efficient, right? So, but if we convert wordDict to a set, when we check if a substring exists in wordDict, that lookup is going to be much more efficient, right? Because we're using a set. So we actually are going to do that just to make our program more efficient, right? In an interview, I think you remember to do this, it'll definitely go a long way, because it shows you're thinking about, you know, having a very efficient program, because you're making sure that your lookups are really fast. Okay. Now we also have to keep track of the maximum word length in wordDict to avoid unnecessary substring checks, right? Because remember, if the longest word in wordDict is of length 4, we don't want to check a substring that's length 6, right? It's pointless and inefficient. Okay, so let's find the longest word in word length, or the longest word length in wordDict. Okay, I'm going to say max word length is 0, right? And we're going to say for const string word in wordDict, right? So if the word.length is greater than whatever max word length is, right, then we can update max word length to word length, okay? Right? And then down here is basically our DP approach. Okay, so this is where we're going to start. So remember, we're going to go linearly through string s. So we're going to say int I 0, I is less than n, I plus plus. Okay. Now, if we find something, right, remember that when that I is wherever it is in string s as we move forward, we're going to check, is that I set to true, that index in DP, in the DP array, right? Which would always be yes initially, right? Because that's the point of DP of 0 being true, right? That's like our base case, right? So if we enter this if statement, what do we have to do? That's where we set the j, remember? J is going to be set to I plus 1. So we're going to say for int j, I plus 1, right? And remember, where does j have to go up to? And the answer is it depends, right? So we want to find the longest, the max word length is basically how far a substring should go. However, there's also a case where maybe our array is smaller than the max word length, in which case we want to take that as our minimum because we don't want to go out of bounds, right? So for example, let's say our array, let's say wordDict only has the word, I don't know, leet. But let's say our s is le, right? Well, when we start here, we don't want to take a substring of length 4 because we go out of bounds. We only want to go up to this last index, right? So that's what I mean when I say we have to, it depends on whether, it depends on the length of our array as well as the length of how big our substring should be, because one can take precedent over the other depending on if our array is too short, or whether maybe our array is not that short but in length, but our substring shouldn't go too far because max word length is only up to a certain point, right? So it really depends. I hope you understand what I mean by that. I explained it in the illustration, but I'm just explaining that again in case you don't quite understand, right? So, so I'm going to explain something also, which is that, so first of all, I'll explain it after, right? So in this J, right, what is this for? It's for basically just finding a substring, right? The end of, like, where our substring should end, like up to what point should it go, right? So we're going to basically check, does this substring exist in the set, right? So we're going to do wordDict set find, and we're going to do s dot substring, right? We're going to start at I, and we should go out to j minus I. So for example, if I is at 0, j is initially going to be where I plus 1 should, so it'll be at 1. So well, when we do 1 minus 0 here, we're going to do substring 0, 1, right? But again, it's not inclusive for the ending point, so we're only going to get from 0 up to, but not including 1. So yeah, the I is inclusive, j minus I is not inclusive. Just like Python string splicing, right? If you're familiar with that. But of course, we're in C++. So now we're going to do wordDict set.end, right? So if we find this substring in the wordDict set, we can set the DP of j as true, okay? And then as we keep iterating in this outer for loop, when this I reaches some place where DP of I is true, and it will be because we set it here, then we basically keep doing the same thing, right? We keep seeing if there's other words that we can build out. And so that's kind of how it works. Now, I want to show something, right? So let's say we have a word, like our string s is called word, right? 0, 1, 2, 3, 4, 5, right? So j, in terms of our outer loop, right? J actually it goes up to here, right? That's why it can go to n plus 1, because this is not inclusive, right? Because this is a less than. So technically j doesn't actually go here, but we still have to set it here, right? So j technically goes up to this 4. Technically goes up to this 4. But again, remember, the reason it has to go up to this 4 is because this is not inclusive either. So this is not inclusive because this is a less than. I mean, I could change this to an equal to, right? And change this, write this a little bit differently, but I'm just going to do it like this. So technically this is not inclusive. So technically the j goes up to here. But why does the j have to go up to here if it's out of bounds? You might be asking that. And the reason is because j minus I is not inclusive either. So technically we do from I is 0, right, up to 4, but that doesn't include this 4. So technically it goes from 0 up to 3 in terms of what the substring gets calculated as, right? So we go from 0 up to 4 minus 0, which would be, so 0, substring 0, 4, and 4 is not inclusive, so it technically takes these four letters, right? So just kind of explaining that in case you're slightly confused. I hope that makes sense. Okay. I think this is not true, actually. This has to be set to true. Like this. And, oh, sorry, I forgot to return something. So we have to return the actual last index, right? So if we can build out the string s given a combination, some certain sequence of word dict, then the last index in the DP array will be true, remember, in the illustration? So we're basically, and remember, n is just the s dot length. But anyways, I hope that makes sense. I'll be honest, it's not an easy problem. It's not an easy solution to come up with on your own. It's actually quite difficult. This is not an easy problem, I don't think. Not to come up with on your own, not at all. I couldn't do it. So unless you're extremely, extremely good already at LeetCode and you've done a lot of these types of problems, it's very hard to come up with this on your own. But that's the point of practicing and looking up solutions and looking up help, right? So I hope this helped, and I'll see you in the next one. Peace out.